Okay, this is part 2 of the video. So we're starting off with question 5a. It's 3 marks. The question is, using example in figure 2, which is this thing here, explain how a bitmap image is stored on a computer. So it's basically talking about an image and how a computer will store this particular image. Okay, so an image that is on a computer is made up of pixels. So a pixel is a single dot on the screen, and that single dot can have one color. So the response the examiner was looking for is that an image is made up of lots of pixels, and a pixel can be one color. Each pixel will have a unique binary number. So each pixel is representing a color, and the color is representing a unique binary number. And this binary number is stored in an order. So if we have a look at this example here, if it was W for white, so white and white will be stored in that particular order. So let's have a look at an example. So let's say if the binary code, you can make this up, for white was 3 zeros, for red was 001, and for blue was 110. If we wanted to represent the following, we could do it like so. So we have white here, so that's 000, white again, 000. We have red is 001, so we've got 001. We've got red again, 001. We've got red again here, 001. And then the two blues are represented with 110, 110. So here's our example, and here's how the colors would be represented. Without the spaces, it would look like so. So you get 2 marks for explanation, 1 mark for example. Explain how reducing the number of colors in an image can reduce its file size. We discussed, or we said, that a pixel has an individual color. Each color is stored in bits. So if we're storing less colors, it means we are basically using less bits per color. This also means that there are fewer bits per pixel, because every single pixel has a bit. So the less colors there are, the fewer bits we are going to use. If you said fewer bits on its own, it's not enough. Fewer bits for what? You've got to be clear and you've got to be specific. Question 5c is 2 marks. The final image file may contain metadata. Describe, using an example, what is meant by metadata. Okay, so it's extra data or information about the image that is stored. So if we have an image, it's information about that particular image. That would be 1 mark. So things, so to get a 2nd mark, you've got to give an example. So this could be things like the dimension, so the width and height. It could be the colors that are used, and it could be also the location and file name and file size. It's not enough to just say it tells you something about the image. Well, what does it tell you about the image? You've got to be specific. And 0 marks if you talk about how the image is stored or displayed, i.e. in binary or whatever. Here we've got the properties of an image. We can see the dimensions of the property. We can see the width. We can see the height. We can see the bit depth, which is using 8 bits. We can see the name of the picture, the type, where it's stored, when it was created, when it was modified, the file size, and then the attribute as well. So any of those things, if you can remember, will give you 1 mark for the example and 1 mark for explaining what metadata is. Question 5di and ii is 3 marks and 2 marks. Alex needs to create an audio recording of himself playing his guitar. Explain how sampling is used to make the recording. Okay, so the way sampling works is that samples are taken at regular intervals. The text that is bold, taken at regular intervals, that is what you have to say, it's taken at regular intervals. What is measured? Well, the height and amplitude of the wave is measured. That will give you your 2nd mark. This is stored in binary. Another mark you get there. And the samples form an approximated sound wave. State the effect of increasing the sample rate of the recording. So when we increase the sample rate, it means that the file size will increase because we're taking more samples at regular intervals. It also means that the sound will be better. If you say the sound will be better, you won't get any marks. You have to be specific and you have to say the sound will be better compared to the original. Question 6, say, describe the benefits of using of a dual core processor over a single core processor. A lot of answers you put was it works twice as fast, it's much faster, it does things quicker. They are very vague answers. You've got to be specific about how it's faster. So you've got to say that the tasks can be split between the processors. Okay, so sorry, between the cores. So a processor may have 2 cores, the task can be split between the 2 cores. What does this mean? So to get your second mark, you have to explain your point. This means that the tasks can be processed faster. You cannot get the mark, the task can be processed faster, if you don't have a point at the start. If we didn't have this point, we wouldn't get this mark. It allows multitasking, 1 mark. What does this mean? Well, it means that more than one process or instruction can run at any one time. So you can have 2 applications running at the same time. And that is known as multitasking. Question 6bi is 4 marks. It's looking at the difference between RAM and ROM. RAM stores currently running programs. So anything that you have open on your computer or on your phone is stored in RAM. It's really fast memory. ROM stores the boot up instructions, so it stores the BIOS, it stores the post instructions and the boot sequence the computer goes through. Now, RAM is volatile, so that means that if there's no electricity going to it, it loses that data. However, ROM is non-volatile. The keywords we've got to use is volatile and non-volatile. You've got to remember this, and that's how you get your mark. Non-volatile means that it can store the data permanently. RAM can be changed, it has to. ROM cannot be changed. We can get versions of ROM that can be changed, but for now just think of it as ROM cannot be changed. So you can have 1, 2, 3, 4, 5 marks you've got there, and you can choose whichever one, but again you can only get 4 marks. Quinn has decided to upgrade the RAM on his computer. Explain why this would improve the computer's memory. Well, if a computer has more RAM, it means that more applications can run at any one time. Okay? And if more applications are running at any one time, the software will open faster. We don't have to rely on virtual memory, so we don't have to use the hard drive as the virtual memory or the swap file. And we can run more memory intensive software, so any CAD software or any software with editing videos or graphics will run more smoothly. So 1 mark for that one. It's not 4 marks, that should be 1 mark, I believe. 6 marks. This is again related to Quinn. He wants to upgrade or improve his PC's performance, identify the changes and explain how these changes could improve performance. So 1 mark for the change and 1 mark for how it will improve the performance. RAM has already been selected, so we can't choose RAM. First thing I would do is upgrade the CPU clock speed, 1 mark. Why? Well, this will run more fetch execute cycles. It means we can have instructions processed quicker. We could also upgrade the CPU cores, so we can go from dual core to quad core or single core to dual core. To get the second mark, you will say that more instructions can be processed simultaneously. Okay, so you can have multitasking. We can increase the cache size, and this will increase the speed of the frequently used instructions. So bigger cache size means that you can have more things that are frequently used stored in there. And finally, we can upgrade the hard drive to solid state. What will this do? Well, this will improve the read and write speed. And again, solid states don't have moving parts, they're quiet, they use less energy, and they're much more reliable as well. The graphics card could also be upgraded, and this just improves the quality of the graphics and the speed. So the keyword here is the quality and the speed. You could also say that the graphics card will the graphics card CPU could also be upgraded so that it relies less on the main CPU for processing. Question 7a, 2 marks. The difference between LAN and WAN. LAN is local area network. You won't get any marks if you just say that. You've got to expand. It's used in a small geographical location. That's the keyword the examiner is looking for. So, things such as homes or office. LAN has its own cable and infrastructure. So, everything that you have within LAN, you can see the cables. It has its own cables and setup and structure. It has its own switches. It has its own servers. It has its own wiring system and so on. WAN is wide area network. That's not enough to say. You've got to look at the text that is in bold. It covers wide geographical location. Yeah, so it's used to transmit data over a larger distance. This could be cities, it could be countries, and so on. So 1 mark for saying it's a small geographical location, 1 mark for saying it's over a large geographical location. Question 7b is 2 marks. Benefits of using a client server network instead of peer-to-peer. Well, all of the files are stored in a central location. Okay, so when you save your documents or when you save anything in your documents are stored in a central location. So it means that they're easy to back up. And again, if we have files in a central location, we can update it from different places. So because the files are in one place, the backups are central. You don't have to back up individual computer. So they don't have to go into your documents and back everything up. They can just back it up from one single place. So all of your documents stored on a server, they just have to back up that drive. You can also monitor the clients. You can see what they're doing. Think about a school. The school uses the software Impera, and they can see what you go on. They can see the things you type. So again, it makes it easier to monitor your clients. And finally, you can update the software centrally. So if you update the software from one place, that basically updates all of the other softwares on the computer. You don't have to go to each computer to update them. Question 7c, the difference between World Wide Web and the Internet. A question a lot of people got wrong. The World Wide Web is a collection of websites. It is web pages that are stored on the server. The Internet is the infrastructure. It's the backbone. It connects networks together, and it's a collection of networks. So 2 things to take away. The World Wide Web is just web pages. The Internet is the infrastructure. It's the collection of networks. So 1 mark for each of those statements. Question 8a and b, 191 into binary. So what we do is we create our table first, starting from 1 and going all the way to 128. Then we try to use these numbers. We can only use these numbers once. We try to use these coins, if you want to think of it that way, or these numbers, to try to make 191. So we need a 128. If we use a 64, it will be 192, so it's too big. We use 32, so that will make it to 60, 76, 84, 88, 90, 91. Yep, so that is 191. 1 mark. Question B, 8b is the addition. So we need to know the following rules. Once we know the rules, straightforward. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 0 is 0. Sorry, 1 plus 0 is 1. And then 1, 1 is 1, 0. So I've put the numbers here and here. So we start off here. So 1 plus 1 is 0. So this set of rows is the carry. So 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 0 plus 1 is 1. 1 plus 0 is 0. Sorry, 1 plus 0 is 1. So 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 0 is 1, so we put 1 there. 1 plus 1 is 0, carry the 1. 1 plus 0 is 1. 1 plus 1 is 0, carry the 1. 1 plus 1 is 0, carry the 1. 0 plus 0 is 0. 1 plus 1 is 0, carry the 1. 0 plus 1 is 1. Then 1 plus 0 is 0, 1. 1 plus 0 is 1. I know it seems confusing, but it's just about trying with small numbers. Try with only a few numbers first and then moving on to bigger numbers. So just try using 2 bits, like adding 1, 0, 1, 1. 1101. Once you get used to it, then you can add bigger numbers, but try to use the following rules to help you. The last question we'll do in lesson, because we need to do some pseudocode for that. So this finishes the set of questions for the 2016 A451 paper.